Welcome to Chapter 2, Homework Questions 104 through 108. Question 104. Draw a right triangle with legs of length 6 and 8 units, respectively, onto graph paper. Construct a square on the hypotenuse and use the square's area to find the length of the hypotenuse. So this problem really comes directly from the core problems in the book, but it was question 99, so you might not have done it. If you didn't, this is kind of how it will work. So we're going to do a length of 6 and 8 units on the leg. So we'll go 8 this way and 6 this way. Now actually I'm going to fix this because I want to give myself some room to rotate it. So we'll go 8 here and then 6 this way. And then if you go back and look at question 99, and we're going to rotate the right triangle around, and what it'll do, it'll construct a square on the hypotenuse. So I'll show you how this works. And so we're going to take the first one and we're going to move it and rotate it over here. So now this length of 8 will now move over here and have a length of 8. So 2, 4, 6, 8. And then it'll have 6 units this way. 3, 4, 5, 6. So it's the same triangle, just rotated and either shifted over, or you can rotate it at a certain point. And then we'll do that again. And so then this length will be 8. So this represents 8. This represents 8. And then, whoops. And then this would represent 8. So you can see the side lengths. And then you have 6 here, 6 here, and then we'll do 6 in this direction. And then we'll do one more on this last side. And we'll go once again 8 in this direction. And then we should have 6 left. 2, 4, 6. And so then what you notice is this right here, inside here, will represent a square because we're using the hypotenuse of the right triangle on each side. So it definitely represents a square. And so we're going to construct a square on the hypotenuse, which we just did, and then we're going to use the square's area to find the length of the hypotenuse. So what we can do is we can find the area of the entire thing, because that's just one big square. And what you'll notice is the side lengths on each of these is 8 and 6 all the way around. Okay? So therefore the entire side would be 14 by 14. So the area of the big square is 14 squared, so that's 196 units squared. And then what we can do is we can take and find the area of a single triangle. They're all the same. Remember, all these areas are the same, but once we find one of them and multiply it by 4, that'll give us the area of kind of the shaded region that I've just shown you. And then when we subtract those two, it'll leave us with the square and sides area. So let me erase some of that. So now we're looking at the area for the triangles. So that's 1/2 base. And since it is a right triangle, the height does represent a side length, so base times height. So that would be 24 units squared. Now that's just one triangle, so we're going to take 4 times 24, so that gives us the area of all 4 of them. And so that would be 96 units squared. So we're going to take the big triangle, or the big square, and subtract the area of the 4 triangles. And that will give us 100 units squared for the area of this inside square. Now, it wants us to take that idea and find the length of the hypotenuse. Well, if we know the area, then we know, and we'll call this just x all the way around here, that we know to find the area of a square, we take the side length times itself. And so if that's equal to 100, then what must the side length be? It must be 100 units. So therefore the hypotenuse is the square, 10 squared is 100, so the hypotenuse is 10 units long. And so I just wanted to verify, making sure that I did answer the question here. Question 105. One of the algebra topics you have reviewed during this chapter is solving systems of equation. Assess what you know about solving systems as you answer the question below. Part A. Find the points of intersections of the lines below using any method and write your solution as an ordered pair. So to take the first one here, I'm going to use the equal value method. So I'm going to set, since they're both y equal, I'm going to set them equal to each other. And then solve, I'll subtract the x and then subtract the 8. So it looks like we get x equals 5. Plug that back into one of the two equations. I'll just plug it into the first one. That's negative 5 plus 8. And so y is equal to 3. So the solution would be 3 comma 5 for that. On part 2 here, change colors. Part 2, now we can use substitution because since y is equal to on the second one, I can substitute that back into the first one. So we get 2x minus what we're going to replace y with, which is negative 4x plus 2 is equal to 10. We'll distribute the negative, so it'll be 2x plus 4x minus 2 equals 10. 6x, add the 2 is 12, x is equal to 2. And then we can plug that back into your second equation, y equals negative 4 times 2 plus 2. So negative 8 plus 2 is negative 6. Therefore, the ordered pair would be 2 comma negative 6. So that's once again solving a system. First method, equal value. Second method, use substitution. The third method that we learned in algebra is elimination. All right, on to part B. Find the equation of each line on the graph below. Remember the general form of the line in slope-intercept form is y equals mx plus b. So let's look at line, we'll start with line P. So it looks like it crosses the y-axis at 0, 8, and we can draw our slope triangle in here. It looks like it goes up 2 and over 1. And so, once again, up 2 over 1. It looks like if I keep doing this, I still get the same thing. So it looks like my slope is 2 with a y-intercept of 0, 8. So we got y equals 2x plus 8. For line Q, on this one, it looks like the y-intercept is at 0, 3. This one's decreasing. It looks like it's going down 1 over 2. And you can see, just to make sure that we're seeing the same thing. So down 1 over 2, I did a couple of them so you could see that. So y is equal to negative 1/2 x plus 3. And so those would be the two equations. On part C, what is the relationship between the lines in part B, and how do you know? Well, if we're looking at the slopes of the lines, we notice this one's 2 and this one has a slope of negative 1/2. And why is that important? Because the perpendicular slopes are opposite reciprocal. So to answer part C, we know that the lines are perpendicular. And once again, how do we know that? Slopes are opposite reciprocal. All right, on to part D. Solve the system of equations you found in part B algebraically. Verify your solution matches with the one shown above. So since they're both written as y equals, we'll use the equal value method again on that one. 2x plus 8 is equal to negative 1/2 x plus 3. I'm going to add the 1/2, so that's 2.5. I'm going to write that as an improper fraction. So it'd be 5/2 x. I'm going to subtract the 8 to the other side, and that would be minus 5. I'll do this in 2 steps. Multiply by 2, so that's 5x equals negative 10, and then divide by 5, and x is equal to negative 2. Does that match up with where the solution is right here? Right there is where the intersection is, which is at negative 2 comma 4. So that looks good there. Then we'll take the negative 2, plug it back into the equation of 2x plus 8. And that's negative 4 plus 8, which is 4. So the ordered pair is negative 2 comma 4. And that does match up with what was in there for the graph. Question 106. Lines P and Q graphed in problem 105 form a triangle with the x-axis. How can you describe this triangle? In other words, what is the most appropriate name for this triangle, and how do you know? So we're going to form the triangle here all the way down to the x-axis and then over. So this is the triangle that it's talking about. So what do we know to describe this triangle? Well, we found out the slopes were perpendicular. Whoops. And so we know that this forms a right angle. So therefore, on part A, we know we have a right triangle. And how do we know that? And we know that because the slopes are opposite reciprocal. Part B, find the area of the triangle. Area is equal to 1/2. We'll mark this as our base. And then we have, well, maybe not. Maybe we'll do it this way. We'll mark this as our base because we know the distance of this we can count. It's from -4 to 6, so that's 10 units. So that'll represent our base. And then the height, we can go from this vertex straight down, and that represents the height. Once again, that's something we can count, which is 4. So therefore, our area would be 1/2 of 40, and that is 20 units squared. And then on part C, what is the perimeter? So we know that this length right here was 10. We need to figure out this length and this length to figure out what the perimeter is. To find the perimeter, we have the 10 as I said, and then this length right here, if you know what Pythagorean theorem is, some of you might choose to use that. We haven't really introduced it in this course just yet. But this side length would be 2 and this would be 4, and you could use Pythagorean theorem if you know how to do that. Otherwise, we could also use the rotation, so we could go back to this question and do both sets of triangles if we wanted to do that. Or we can just kind of estimate. So at this point, I'm just going to estimate the length here. So we know that the perimeter has 10 units on this side. And then on this side, if this is 2 and this is 4, this maybe is approximately a little bit larger than 4. So we're just going to call it 5 for now. And then if we look at the other one, we have 4 on this side. And over here, we have 8. So this has to be a little bit bigger than 8 as well. Once again, we might be able to approximate a little bit better here. But if we just call it 9 for now, that'll give us approximately 24 units for the perimeter. And once again, this is really just an estimate as to what the perimeter is. If you wanted to be more accurate, you could use Pythagorean theorem if you know how to do that, or like I said, go back to question 104 and use the idea of the rotation of the triangles to figure that out as well. Question 107. Examine the diagram below. Based on the information in the diagram, which angles can be determined? Copy the diagram on your paper and find only those angles that you can justify. So let's take a look. First one we can go with is the vertical angle, which is 74 degrees. Also recognize that these two lines are parallel, but the other two, even though they look like they are, they don't indicate that they are, so we can't make that assumption. So we can look at the two parallel lines cut by the transversal, which means we know corresponding angles. So that would be here and here. Those are also vertical angles. Would be the same, and then we can take 180 and subtract 74 and get 106. And we can do vertical angles, we can do corresponding angles, a lot of different ways that you can mark all of those. Once again, you got vertical, you have alternate interior, you have same side interior. So once again, a lot of straight angles, a lot of different things that you could answer for that. But what we don't know is we don't know anything about these set of angles over here because we don't know that those two lines are parallel. If they were, then we could answer those 8 as well, but we don't, so we got to leave those blank. Question 108. On graph paper, plot A, B, C, D, and then what type of shape is it and justify your answer. So I'm going to go ahead and plot the 4 points, and then we'll take a look and see what shape it is. So after plotting the points, we see that it is a trapezoid. There's one set of parallel lines here and here, and so we do know it's a trapezoid. And make sure you justify your reasoning, one set of parallel lines. Part B, if the quadrilateral ABCD is rotated 90 degrees counterclockwise about the origin, name the coordinates of the new image. So we are rotating around the origin. So use tracing paper, rotate that around the origin, and these would be your new points. Alright, so those are the new ordered pairs for A prime, B prime, C prime, and D prime, and then the picture below as well. On your graph paper, reflect ABCD across the y-axis to find ABCD double prime, and then name the coordinates of A double prime and C double prime. So we're reflecting it across the y-axis. So I went ahead and did it on the same graph. I probably should have erased first, but that's alright. So you can see the new one, I labeled A double prime and C double prime, and then part D is to find the area of ABCD and showing all your work. So remember, since we're trying to find the area of the trapezoid, we're looking for 1/2 times the height, and then base 1 plus base 2. So with all the stuff I have now going on, go back to the height right here. How tall is it? That would be 3. So the area is equal to 1/2 times the height of 3. And then what is the base? So once again, if I could go back and fix all this, I would. But you can see the base right here between these two represents 2. And then the base on the bottom, you have 1, 2, 3, 4, 5, 6, 7. So if we figure this out, we got 1/2 times 3, and then 2 plus 7 is 9. And then you're going to take 3 times 9 is 27. Half of 27 is 13.5 units squared. And this is for part D, where you're finding the area of the quadrilateral, or in this case, the trapezoid.